Okay, here's a picture of two different types of elevator systems, and what we're going to look at now is how the tension forces are involved here in a situation where you have a hanging object, where we have, in this case, there's a counterweight over a pulley, and then, the actual motor here is pulling the whole system up. This one, the motor's up here, and this is all interconnected with the counterweight and the elevator itself. So this is called an Atwood machine. We have two masses over a wheel and axle. It's just a string that's going over the top. It's not wrapped around it. It's just going over the top. So the tension is felt the same all the way, on both sides here. And what we're going to do is we're going to bend the axis again to help us out. And so as we think through that, we have the coordinate axis going all the way around, positive x going down here, negative x going over here. So what we're going to do is set up two separate free body diagrams. We'll set one up. Our goal in here is to figure out what is the tension and then what is the acceleration of this system. And so we're going to set up two separate free body diagrams like we did before. Tension going up, force of gravity going down. And so for mass 1, sum of the forces equals mass 1 times acceleration. Tension is pointing in the positive, right, this way, which indirectly will be like that. So the positive, so positive force of tension plus the negative force of gravity, which would be m1g equals m1a. And then for the other one, you've got tension this way, force of gravity this way, this is mass 2, so sum of the forces equals mass 2 times acceleration, and we have the negative force of tension plus the positive m2g equals m2a. And just like we did before, we have two equations, two unknowns. Well, I'm going to see if you could solve for the equation of acceleration, which is combining these two together. And let's see if you can do that and determine what the equation for acceleration would be for this system by substituting. You're going to bring this over to the other side, and then you'll have the tension equals these values here, which you can substitute in here. So do your best, and you can hit pause, and then when you're ready, you can hit play and see how you did. Okay, so we've got the positive force of tension plus negative m1g equals m1a. Just like we unpacked before, we isolate for force of tension, place it in there. The key here is remembering to distribute the negative. Hopefully remember to do that. So the negative we've got here, we've got that here, and we can solve for acceleration. Bring this over to the other side, isolate for acceleration. So this is the equation for the system. Acceleration is a g m2 minus m1 divided by m2 plus m1. So let's say the mass of mass 1 is 49 kilograms, mass 2 is 175. Go ahead and calculate the acceleration as well as the force of tension, and you can hit play when you're ready. So go ahead and pause it and give it your best shot there. Okay. So we should give an acceleration of 5.51 meters per second squared with a tension force of 750.19 newtons. And that is how much tension would be felt in the line. Okay, so why don't you go ahead and try to do this from scratch. You can still set up M2 over here, mass 1 over here, and go ahead and see if you can derive this equation from scratch, getting the acceleration equation without looking as best you can. Obviously if you need to look back at your notes, you can, but give your best shot. See if you can write out the equation for the motion using the two separate free body diagrams and the sum of the forces. Okay, so we've got their two equations. One on the left side, mass 1, positive force of tension, negative force of gravity, and equals m1a. And for mass 2, negative force of tension plus the positive m2g. And we can substitute, bring it in, isolate for acceleration. So we should get the acceleration of the system and let's get there.